Right, so hello everyone. This is AS Level Math, summer 2014. Question 1 is all about the transformation of graphs. When you have a coefficient in front of the sin x, it's basically telling you that it's stretching the graph vertically by a factor of b. And when you have a constant, it's always a vertical translation. In the if a is positive, it's in the positive y direction. If a is negative, it's in the negative y direction. So let's just look at here. The original sine graph has a equilibrium position at the origin, and now we can see that it's displaced from the origin to 1. So we can deduce from that a equals 1. And now we can see the second point is that the displacement from the equilibrium position is 3 minus 1, that's 2. So we can deduce that y is equal to 1 plus 2 sine x. For question 2, it's quite a simple application of completing the squares. So as always, there's always the direct method where you first do observe same as 3 squared, and then you can spot again that it's adding 3, which is not existent in the original expression. So you need to minus 3. If you can't directly observe that, you can always expand the already factorized completed expression . And then compare coefficient. For the second part, it obviously follows from the first part. It's teaching you how to solve a second order inequality by using the technique of completing the squares. So we already know that 2x minus 3 squared minus 9 is equivalent to this expression. And we want this to be greater than 7. So 2x minus 3 all squared, then 16. And because when you take the square root of something, there's always a positive or a negative possibility. So we'll have to consider that a is 2x minus 3 is greater than 4, or that 2x minus 3 is less than minus 4. So this expression is equivalent of saying that the modulus of 2x minus 3 is greater than 4. You can also draw a graph to help you interpret this result. So let's try to draw the graph of y equals 2x minus 3 squared. Well, we can just, by observation, that it's never negative, and it touches the x-axis at x equals 3 over 2. So it will look something like that. And you want the value of the function to be greater than 16. So you can draw a line y equals 16, and you'll see that there'll be two different regions. And that's kind of the intuition behind second order inequality. Okay, question 3. Now you're trying to expand a binomial product. And the formula for that is, it's actually easier to just write it. You should sum from 0 to 8. 8, choose n. People write it as a, c, n, but it means the same thing. And 4x cubed of n and 2x of m. And this is just the formula for binomial expansion. And in order to find the term independent of x, which is just the constant term, you want the power of x to be 0, which is equivalent of solving this equation, 3n plus 8 minus n is equal to 0. So you're trying to make sure that the index of the term, of the x term is 0. So that will give you n equals 2. And then substitute that back into this expression. You'll find the required term. Question 4. Well, when you see a question about the tangent of the curve, you should always just go straight to differentiation. And here they have a quite unusual statement. Find the equation of the tangent to the curve at the point where line x equals minus 1 intersects the curve. Well, that, if you think about it, that just means at the point x equals minus 1. So it's not really something new. And we'll start by differentiating the original function. So we do d by dx, 4 over 3x plus 1 all squared. We can do it by the product rule. So we first differentiate with respect to 3x plus 1. It will be 4 over 3x plus 1 to the power of 3, and times the coefficient of minus 2, and time the coefficient of 3. And when you work this out and substituting x equals minus 1, you'll find that dy by dx at the point x equals minus 1 would be 3. So we know the tangent has gradient 3, and it has the form y equals 3x plus c. And the next step would be find the coordinate of the point. So we're substituting when x equals minus 1, y would be 4 over minus 3 plus 1 all squared, which is equal to wait a minute. Yep, 1. So that'll give you the correct equation, 3 x plus 4. Question 5, we're asked that an arithmetic progression has first term a and common difference d. So a arithmetic progression is uniquely determined by the first term a and the common difference d. And now it is given that the sum of the first 200 terms is 4 times the sum of the first 100 terms. And from this condition, you can set up a equation. And that will give you a relationship between d and a. So the formula for summing a arithmetic progression is s equal to a half times how many terms there are, so the number of terms in the progression, times the sum of first term plus the last term. Although we're not given the precise value of the first term and the last term, we know that they can all be expressed in terms of a and d in this way. So the first 200 terms, 100 terms, will be a half times 100 times a, which is obviously the first term, plus a plus 100 plus 99d. Because in order to get from the first term to the last term, you are adding 99 succession of common difference. If you think about it, the second term and the first term you differ by 1a, and the third term and the first term differ by 2a. So the 100th term and the first term must differ by 99d. So the condition says that S200 is equal to a half times 200 times a plus 199d, and that is equal to 4 times S100. And from that, you can work out a relation between d and a. That will give you d is equal to 2a. And if d is equal to 2a, then the 100th term will just simply be a plus 99d equals a plus 99 times 2a equals 199a. So question 6 asks you about a composite geometric object. So you have a sector of a circle inside a rectangle, a right angle triangle. And the first is asking the shaded, the area of the shaded region. We know that AB has length 4 centimeter, and the angle CAB is alpha radians. Because we know the angle and one side, we can immediately work out the area of the entire triangle. So area of triangle should be 4 times 4 tan alpha divided by 2. And now we want to know the area of the little sector of the circle. A DE. And that is given by the formula half times radius squared, which is 2 squared, times the angle at the center, so alpha. So the shaded region is just the difference between the triangle and this sector of circle. So it will just be 8 tan alpha minus 2 alpha. In the second part of the question, we are asked to find the perimeter of the shaded region. And so we know side AB. In order to find AC, we can do AC is equal to AB over cos alpha. It's just a application of trigonometry. Because in this right angle triangle, AC is the hypotenuse and AB is the adjacent. And that would be further equal to 4 over cos alpha. And we want to know the length EB is just 4 minus 2 equals 2. So the entire area would be DC plus EB plus CB plus the arc DE, and that would just be, so DC would be AC minus AD, so that would be 4 over cos alpha minus 2 plus EB, that's 2, and CB would just be 4 tan alpha, as we've shown before, and then D is 2 alpha, and that will give you the correct answer. Question 7. Well, it's combining some geometrical feature of the plane and simultaneous equation together in one question. So the coordinates of point A and B are A, 2. Let's just try to draw a diagram. And 3, respectively, where A, B are constant. AB is square root of 125 units. That's the same as saying that A minus 3 squared plus B minus 2 is equal to 125. That's just Pythagoras. The second condition is that the gradient of the line AB is 2. So after our first equation, we get a second equation from the condition. The change in y coordinate, B minus 2, divided by the change in x coordinate, 3 minus A, is 2. We can quite easily spot that by substitute B minus 2 equals 2, 3 minus A into our first equation, we'll get a second order equation of A, and that will help you to solve the value for A. So after some working, you'll find that A plus 2, A minus 8 equals 0. So we have two possible values of a. Either a equals -2 equals 8, and that gives you the corresponding value for b equals 12, b equals -8. Question 8. We're working with two vectors, OA and OB. And in the first question, find the value of P for which angle AOB is 90 degrees. That condition can be translated in the language of dot product. That the two vectors are perpendicular. That's the only so that the only way it can be perpendicular is the same as saying its dot product is 0. So we have OA B equals 0. So write that out in terms of 3p 4p squared dotted with minus p minus 1p squared is 0, and you just multiply term by term together, you get minus 3p squared minus 4 plus p to the power of 4 equals 0. And from that, you can factorize p squared plus 1 p squared minus 4 equals 0. And the only way to find real solution for this question is by setting p equals plus or minus 2. And for the second question, we are asked that now if p is equal to 3, what's the unit vector in the direction of BA? So we need to first find B, and BA is the same as OB minus OA. And by substituting the value of P as 3, we get 9, 4, 9 minus sorry, I made a mistake here. It should be OA minus OB. So an important point here is that the arrow is always pointing towards the vector that's being subtracted from. What I mean by that is that if it's OC minus OD, the arrow would pointing from D to C. So it will be something like DC. And minus 3 plus 1, 9. And that will give you 12, 5, 0. And this is obviously not a unit vector because its modulus is not 1. Its modulus would be 13. So we can work out, show that its modulus is 13. And so the unit vector would be 1 over 13, 12, 5, and 0. Question 9. The first part of the question is asking you to prove a algebraic identity of trigonometry. So the simplest way of doing it is just showing that if you combine the terms on the right-hand side together, it will equal to the terms on the left-hand side. So if we just combine the terms together, so now the common denominator would be 1 minus cos theta, sine theta. And on the numerator, we have sine squared theta minus 1 plus cos theta. So on the top, we have sine squared minus 1 would give you minus cos squared and plus cos squared. And we can see that we can take out a factor of 1 minus cos theta from top and bottom. That will leave you with a cos theta over sine theta, and that's the same as 1 over tan theta, which is the left-hand side. And armed with the discovery from part 1 of the question, we can solve the equation in part 2 by noting that it's the same as saying that tan theta, which is this expression, is equal to 4 tan theta. And that's saying that tan theta squared is equal to 1 over 4. Must be either plus or minus a half. And you can solve that by using your calculator. And you will get 2 answers. So 26.6 degree or 153.4 degree. Question 10. So now we're seeing a function, a graph function that's not smooth. It's jointed together by 2 functions. So between the region minus 1 and 1, the function has equation 3x minus 2, and it's a straight line. And between the region 1 and 4, it follows the formula f of x equals 4 over 5 minus x, and that has a shape of a curve. And from question 1 is asking for the range of f, because we're already given the graph of the function, and from the function it's quite obvious that it's an increasing function. So in order to work out the range, we just need to work out the value of the function at the endpoints. So when x is equal to minus 1 of x is equal to minus 5, and when x is equal to 1, f of x, 4, f of x would be 4. So the range of f of x should be between minus 5 and 4. And the second part, copy the diagram on your own copy and sketch the graph of y equals the inverse function of f of x. So the trick of drawing the inverse function is that you have first draw the line y equals x as best as you can. So this is the line y equals x. And then you have to reflect the function in the line y equals x. So that will be something like that. And this is how you draw the inverse function. And obtain expressions to define the function f inverse, giving also the set of values for which each expressions is valid. So so it's asking you to find the inverse function, but also asking you to find the domain of the inverse function. And it's clear that the domain of the inverse function is the range of the original function, because you are going between two sets, and when you do the inverse, you are just exchanging these two sets. So the line, you can just see by observation that the inverse function should be a third x plus 2, and that would be valid between the range of the original function, so it'll be between -5 and 1. And for the curve, we can set y equals 4/5 minus x. So that would lead to 4/y is equal to 5 minus x. So x is equal to 5 minus 4/y. So the inverse function would be 5 minus 4/x. And now the domain of the inverse function is the range of the original function. So the range of the original function is just s is greater or equal to 1 and less or equal to 4. Now we can move on to question 11. A line has equation y equals 2x plus c, and the curve has equation y equals 8 minus 2x minus x squared. For the case where the line is tangent to the curve, find the value of the constant c. Well, if the line is a tangent to the curve, we can now compare the gradient of the two functions. So for the curve dy by dx, let's just make sure it's clear it's a curve, would equal to 2 minus 2x minus 2. And at the point where they are tangent, so basically at the point where the line is tangent to the curve, we must have that minus 2x minus 2 is equal to the gradient of the line, which is 2, because at the point where the line touches the curve, the gradient must match, otherwise it will intersect. So from this equation, we'll find that x is equal to So x is equal to minus 2. So minus 2 is the point of tangent. And now substitute that back into the equation. And that'll give you 0. And so substitute that back into the equation of the line. Equals 2 times minus 2 plus c equals 0. Wait, I think I've done something wrong here. Yeah, so because it's minus 2 here, so it will be a plus sign here. So y would be 8 for the curve. And so there should be 8 here. And that will give you c is equal to 12. So that's part 1 complete. And now let's move on to part 2. And now we're given a new value of c. So we have y equals 2x plus 11 for the line. And we have y equals 8 minus 2x minus x squared for the curve. So find the x coordinates of the point of intersection of the line and the curve. So we just equate the two expressions. And we'll find that it would factorize into x plus 1, x plus 3 equals 0. So the curve and the line will intersect at two separate points, x equals 1 and minus 1 and x equals minus 3. And after that, we'll just need to do the integration of 8 minus 2x minus x squared. That's the area of the curve. And then minus 2x plus 11. That's symbolize the area of the line, under the line. Dx. And then apply the limits. That'll give you 1 1/3. So for question 12, a curve is such that its derivative is given by x to the power of half minus x to the power of minus half. And we're given that the curve passes through the point 4, 2/3. And the first question is asking us to find the equation of the curve. It's equivalent to a first order differential equation. So in order to find the equation of the curve, we first do a integral both sides of the derivative expression to find y is equal to constant. And in order to quantify this constant, we need to substitute in the point 4, 2/3, and that will fix the constant to be minus 2/3. Part 2 is asking for the second derivative of y. Second derivative of y, we just need to differentiate the first derivative once more, and that will give you a half x to the power of minus half plus a half x to the power of minus 3/2. The final part of the question is asking you to find the coordinates of the stationary point and determine its nature. So first what we need to do is to set dy by dx to 0. So by definition, stationary points are the points at which the derivative is 0. And that will give you a equation to solve. So x to the power of half of minus half equals to 0. So x minus 1 over the square root of x is 0. So that will give you solution x equals 1. So when x equals 1, y is equal to 2, and d2y by dx squared is equal to 1, which is greater than 0. So if at the stationary points the second derivative is greater than 0, it just means it's a minimum. It's a minimum. Okay.